Beneath your feet, steel leviathans the length of a football field grind through earth and rock, building tunnels so vast entire trains vanish inside. Yet almost no one knows their names, or what happens if they fail. These secret machines, costing tens of millions, are so vital and hazardous that their details are kept classified by governments. But what would happen if one stalled, or worse, ruptured beneath a crowded city? This is the hidden world that shapes modern life, and few ever see how it truly works. Stick around as we reveal what really powers the cities above. Subscribe now to keep watching. Subscribe and turn on notifications to watch the full investigation. A tunnel boring machine, known as a TBM, is less like a vehicle and more like a traveling underground factory. These machines are custom-built for each project, designed to carve through anything from soft clay to solid rock, sometimes for years without surfacing. Each one is so specialized that it is given a name before it ever touches the ground. Names like Rachel, Selena, Bertha that become legend among engineers and city planners. The price tag matches the scale. A single TBM can cost tens of millions of dollars, not including the teams required to operate and maintain it around the clock. Subscribe now to see more deep looks at hidden infrastructure. Instead of digging a hole from above, a TBM moves forward deep beneath the city, grinding away earth with a rotating steel cutterhead at the front. Behind it, a shield protects workers and equipment from collapsing ground, while a series of trailing support cars handle everything from power supply to spoil removal. As the machine advances, it installs concrete segments to create a finished tunnel wall, sealing the void almost instantly. This setup allows construction to continue without closing streets, disrupting traffic, or even alerting most people above that anything is happening at all. The scale and secrecy are not just for show. TBMs are considered critical infrastructure, with their routes, real-time data, and even maintenance logs often restricted by government security rules. Once launched, a TBM becomes a hidden force, working day and night, shaping the arteries of a city from below. Each project is unique, each machine a one-off solution to the puzzle of modern urban life. For the full documentary and source notes, subscribe and check the description. At the heart of every tunnel boring machine, known as TBM, a massive steel cutterhead rotates with slow, relentless force. This is the business end, sometimes more than 17 meters across, armed with hundreds of hardened steel discs and teeth. As it spins, the cutterhead chews through rock or clay, sending the debris onto conveyor belts that snake back through the machine. Just behind the cutterhead, the shield forms a protective tube, holding back earth and water that would otherwise flood the tunnel. The entire machine advances on hydraulic thrust cylinders, each one capable of pushing with thousands of tons of pressure, inching the tunnel boring machine forward, millimeter by millimeter. If you want more deep dives into hidden infrastructure, subscribe to the channel. Precision is essential. Laser-guided navigation systems track the tunnel, boring machines' position in real time, measuring its alignment to within a few millimeters. Operators in a pressurized cabin monitor pressure, torque, and advance rate on digital displays, making constant adjustments to keep the machine on course. As the tunnel boring machine moves forward, an erector arm lifts and places massive precast concrete segments, each weighing up to 16 tons, forming a ring that instantly becomes the new tunnel wall. These segments are bolted and sealed together, locking out water and supporting the city above. Maintenance is a world of its own. When the cutterhead needs repairs, workers access it through a manlock, entering a pressurized chamber that matches the ground pressure outside, sometimes at levels found 50 meters underwater. In these hyperbaric interventions, teams replace worn discs or clear obstructions, working in shifts to minimize time spent under pressure. Every part, from the shield to the trailing support cars, is designed for continuous operation, with crews ready to respond to breakdowns at any hour. Inside the tunnel boring machine, the line between machine and environment blurs, and every advance is a battle measured in centimeters. If you found this revealing, subscribe to the channel for more episodes in this series. London's Tideway tunnel stretches for 25 kilometers beneath the city, with a diameter of 7.2 meters and a depth that ranges from 35 to 65 meters below ground. If you want more deep dives like this, subscribe now to this channel. Excavating a tunnel of this size means moving an astonishing 4.6 million tons of earth. Every night, up to 1,300 tons of spoil is removed, but not by truck. Instead, a carefully orchestrated fleet of barges carries the spoil along the Thames, timed precisely to the river tides. Each barge can hold up to 1,500 tons, and as many as 70 barge trips leave the site each week. This system keeps thousands of heavy vehicles off London roads, reducing congestion and emissions while the city sleeps above. Beneath the surface, the choreography is relentless. Conveyor belts feed the spoil from the tunnel boring machine to loading bays, where teams work against the clock to fill each barge within tight tidal windows, sometimes just 2 to 4 hours long. The logistics team coordinates every movement, syncing with the Port of London Authority to avoid river traffic jams. Precision and timing are critical. If a barge misses its slot, the entire excavation can grind to a halt. The result is a hidden ballet of steel, earth, and water, operating with a precision that rivals any above-ground infrastructure project. Subscribe now to follow the full series on the secret steel machines hidden beneath our cities. A night shift tunnel boring machine pilot on London's Tideway tunnel begins work as the city's lights fade above. Subscribe now to follow this deep dive into the hidden infrastructure beneath our feet. Deep underground, the control cabin sits 50 meters below the surface, insulated from the noise and rhythm of the world outside. The pilot's shift lasts 12 hours, often from dusk until dawn, with only the hum of machinery and the glow of digital displays for company. Every few seconds, data streams across the screens: torque readings, hydraulic pressure, cutterhead speed, and the advance rate. Each number a clue to what's happening meters ahead, beyond the reach of sight. Isolation is a constant companion. There is no window to the outside, just a porthole view of the tunnel face as it creeps forward. To break the monotony, some pilots bring playlists or swap stories with the outgoing crew during shift change. But for most of the night, it is just the pilot, the machine, and the data. The pilot adjusts controls in response to subtle changes: a spike in pressure, a tremor in the cutterhead, a warning from the spoil conveyor. Each decision can mean the difference between smooth progress and hours of troubleshooting. Every movement underground depends on the surface above. If a barge is delayed by the tides or a conveyor jams, spoil backs up and the tunnel boring machine must stop. The pilot's world is defined by routines and rituals, but always shadowed by the knowledge that a single missed signal, a moment's inattention, could bring the entire operation to a halt. Subscribe to follow the rest of this documentary series. Bertha, the 17.45-meter giant beneath Seattle, was engineered to carve a new path for the city's highway. If you want to explore more hidden machines beneath our cities, subscribe to this channel now. But on a December night in 2013, progress ground to a halt. Alarms sounded in the control cabin as the cutterhead's torque spiked, then dropped. Operators attempted to slow rotation and adjust pressure, but the numbers only got worse. Within minutes, the entire machine jammed. The culprit was an 8-inch steel pipe, buried decades earlier and missed in pre-bore surveys. It had wedged itself deep inside the cutterhead. The impact destroyed seals and bearings, leaving Bertha immobilized nearly 20 meters below the surface. Every minute Bertha sat idle, costs soared. Crews evacuated as engineers scrambled to assess the damage. The only way to reach the stalled machine was to dig a rescue shaft, a 30-meter deep vertical pit, large enough to extract the cutterhead for repairs. Over the next 2 years, the project's price tag ballooned by more than $600 million. Contractor and owner blamed each other for the oversight, with legal battles stretching behind closed doors. For Seattle, the hidden risk of building with machines this size became impossible to ignore. If you want more episodes that reveal the infrastructure beneath your feet, subscribe and turn on notifications. Access to information about tunnel boring machines is tightly controlled under critical national infrastructure rules. Subscribe for more deep dives into hidden infrastructure. Detailed maps, real-time performance data, and even maintenance records are often classified as official sensitive, with access limited to vetted engineers and government officials. This secrecy is not just about protecting against sabotage, it is also a way to manage liability and insurance risk. When a breakdown leads to delays or damage, as with Bertha in Seattle, the owner and contractor can end up locked in confidential legal disputes, each side guarding technical data that might determine who pays. Insurance policies for these projects are written with exclusions and sublimits that hinge on the smallest details, whether a failure was caused by a design flaw, an undiscovered obstruction, or a lapse in maintenance. The result is a system where even the most basic operational facts are shielded from public view, making it difficult for outsiders to fully understand what went wrong or how costs spiraled. But the next generation of tunnel boring machines may change that equation. Manufacturers are now embedding AI-driven sensors directly into cutterheads and support systems. These sensors collect thousands of data points per second, measuring vibration, torque, and ground composition, and they use machine learning to predict failures before they happen. In recent pilot projects, predictive maintenance has reduced unplanned stoppages by up to 50%. The hope is that AI can provide a real-time safety net, flagging risks, documenting conditions, and creating a transparent digital record that is harder to dispute or conceal. As cities push for ever larger and deeper tunnels, the combination of advanced monitoring and smarter machines could make the hidden world beneath our feet not only safer, but more accountable. If you want to explore this further, subscribe now and turn on notifications. Every day, tunnel boring machines expand the arteries of our cities out of sight, but never out of consequence. As urban populations surge and infrastructure ages, what happens below directly shapes life above. The next time the ground trembles, remember, progress and risk still travel together beneath our feet. Subscribe to our channel for more investigations into the hidden steel machines beneath our cities.